When we use the term linear with respect to anything in mathematics, we're talking about something that could actually make a straight line. So when you get a linear number pattern, for example, a really easy one like 3, 5, 7, 9, it's going up in twos, and if you had to put that sequence on a Cartesian plane, you'd get something that looks like a straight line. So with mathematics, a lot of things cross over, and the word linear is useful because if we remember that links to straight line graphs, and when we study those, we'll remember that linear number patterns work exactly the same way. So there's 3 different kinds of questions that you get asked when it comes to linear number patterns. The first one is to find the formula, and what they're asking you for is they want Tn equals something, and there will be an n in this formula. They also might ask you to find the nth term. It's the same question. Or they might actually say find Tn, or the general term. The second kind of question they can ask you is to find the 4th term or 3rd term or 450th term. They want you to find an actual value for one of the terms in the sequence. This can also be asked in this way. They can say find T4. And what they're asking you for here is they're asking you for the value of a particular term. So they want to know what is the number that is in the sequence. So in this case, the 4th term is 9. Its position is 4, but its value is 9. And it's really important to distinguish between the value of a term and its position in the sequence. The third type of question tends to start with these words, but not always. They ask you which term equals 95. And what they're actually asking you for is the position. So they've given you the value and they want the position. So for example, if I said in this sequence, which term equals 9, you would say term 4. You would say the 4th position is the one that has a value of 9. The other kind of question that you get will be one that has pictures. Those come up quite a lot in grade 10 exams and sometimes in grade 11 and 12 as well. So it'll be something with dots and matchsticks, and they'll say that's the first one and the second one, and they'll say how many dots are there, and you might have to get a formula for the dots, and you might have to get a formula for the sticks, and so on. They're basically an application of everything else, and they work exactly the same way. There are a few different ways of writing formulas for linear number patterns. I find this one the most useful, and it takes you all the way up to matric. There's just one change I would make to it from the way it is normally given. Because you have to multiply the d into your n and -1, and that causes problems for some people, I will always put a bracket by the d so that I remind myself that that is being multiplied into the previous bracket. It's not something that is being added on. That gets particularly confusing when the d is negative, because then we start seeing a negative here. So for example, if we had something like the first term was 2 and we have n minus 1 and then it was -3, people don't realize that that has to be multiplied in. So that's why I will put that bracket there. Okay, so what does everything stand for? Your A is the first term in your sequence. Okay, it's also T1. So if ever they're asking you for T1, you will know that it's talking about the first term, which is also denoted by A. Your D is your common difference. So when we're dealing with a linear pattern, it goes up in the same amount every single time. And if I remind you of the one I started with, if we say 3, 5, 7, 9, and that continues, what you'll be able to see immediately and how you will know it's linear is that to get from 3 to 5, you have to plus 2. To get from 5 to 7, you have to plus 2, and so on. And so what this is, it is a common, because it is common between all the terms, it is the common difference. It's called the difference because if you take T2, so that's T2, and you minus T1, which is the first one, so 5 minus 3, you're going to get 2. And if I take, say, T3, and I minus T2, so 7 minus 5, I'm going to get 2 again. So you will always know that a pattern is linear because this works. If you minus a term from the one that comes after it, you always get the same common difference, and we have that as a D in the formula. So what does the N stand for? The N is your position. It's the term number. And in mathematics, wherever you see a variable mentioned twice in the same mathematical construct, so there's an N and there's an N. If that happened to be T2, then the N there would be a 2 as well. If that was 45, then that would be a 45. So N is consistent throughout, and if you know that one, it means you know that one as well. So in those questions, when they say to you, what is T4, you will merely sub in a 4 into your N value so that you can then calculate, because it means exactly the same thing. Right, so back to how to find the formula when you're given a sequence of numbers. Okay, so you're going to check that it's linear, because it might not be, and this only works for linear ones. You're going to see what is the difference there, and you're going to see that it's constant. When you see that it's a common difference, you know your D value. Okay, so while you're getting used to it, I would always recommend writing out the formula every single time you solve one of these problems. And then we're going to see whether we know what A is, and we're going to see whether we know what D is. The N we would need if we were being asked a question about the position. But right now, if we're asked for the formula or the general term or the nth term, you're going to have an N in the formula, so you're not solving for N. Okay, now remember that A is the first term. Even though we could say that's T1, T2, T3, T4, etc., that is the term number, but the term value is 3. So T1 equals 3, so A equals 3. We also know the common difference is D, so we know that it's 2, so our D equals 2. Right, subbing back into the formula, what I have is A is now 3, and I don't know N, and I don't have to know N at this point. My D is 2. Okay, now critically, and why I put this in brackets, is I'm going to be multiplying that in backwards. You could move it and put the 2 before there if you want to, but we're going to use it in this way later on, so it might be better to get used to distributing in backwards. So here, I'm going to have my 3 there, 2n, and then 2 times negative 1 gives me the negative 2. I now need to collect my like terms, and there's a convention where I'm going to put the one that's got a coefficient with n first, and then I'm going to collect my constants, which are the other numbers, the normal numbers, towards the right. So I'm going to put the 2n there, and then I'm going to add these like terms. So 3 plus negative 2 is going to give me 1. So this is the general term for this linear number pattern. Okay, let's just prove that this actually works. What we're saying is that if I put a 1 in there and a 1 in there, I should get out the first term. So I'm just going to do a little check. Initially, you can do these to remind yourself or to prove to your brain that you are getting it right, and then you will eventually believe it and you won't have to do it. So what I'm going to say here is, would T1, if we substituted a 1 in for the n, would that give me what's on that side? So T1, I'd have to put a 1 by the end, so 2 times 1 plus 1, so 2 plus 1 is 3. That's correct, isn't it? And we can do the others just in our head. So T2 would be 2 times 2, which is 4, plus 1, which is 5. Yes, it works out. So that means I can get any value if I know the term number. And actually, I can also get any term number if I know the value. So let's try one of those where they ask you for the value. And I'm going to use T4 simply because we actually know the answer to T4. So when we get it using different methods, it'll be a little bit more intuitive. So if I want to find T4, what I've got to do is I've got to substitute that 4 into the n. So when they want the value, they're asking for the T4. And they're asking you to calculate it, okay? So what I'm going to do is I'm going to sub in n to find my Tn. This happened to be 4 and 4, okay? And when I have to find the position, it's a very different task. So I'm going to write out my formula. So it's 2n plus 1. And I'm going to sub in a 4, because I want to know what is T4. I'm going to say 2 times 4 plus 1, which is 8 plus 1 is 9. So T4 equals 9. That is my answer. And of course we can see it's correct. But what when they ask it the other way around? Again, I'm going to use one where we already know the answer, so that when we arrive at it, it makes sense. So if I say which term is equal to 9, then the 9 has to be subbed in for the Tn, because what I'm doing is I'm finding the n. Okay, so that number goes in place of Tn because I'm being told the value. So I've got that and I want that one. So again, same formula, I've got Tn equals 2n plus 1, but now what they're asking me is which term equals 9. When 9 is the Tn, what is the n value? So I'm going to sub in 9 for the Tn. And now what I don't know is that one. If we look in the previous example, I still needed to know what T4 was. I didn't have a value, and that's what I got out. Now I'm saying when they give you the value and you have to figure out the position, okay, then we're going to sub it in a different way. Okay, so that is 2n plus 1. Now it looks like a really normal equation where I'm just going to solve for n. Okay, so I'm going to take that 1 across there, so I'm going to be left with 9 minus 1, so 8 equals 2n, and then I'm going to divide both sides by the 2, and I'm going to have n equals 4, which I knew to begin with, but now we can see how we get it when we're trying to find the position. So when we're finding the position, we're finding n, and when we're finding the value, we're finding the Tn. In this example, when we test to see if it's linear, we see that the difference between 4 and 2 is 2, right? Not quite. Remember that you have to say what is T2 minus T1. So what's 2 minus 4? And that's negative 2. And again, 0 minus 2 will be negative 2. I've chosen this example because when the common difference is negative, it can easily slip our minds, and when we see that the difference between those numbers is 2, we automatically go with a positive number, and that's not the case. Okay, so here we can see that our a value, our first term, is 4. We know that our constant difference is negative 2, and what we're going to do now is plug it into that formula. So I'm writing out the formula every time, and that's a really good habit because we do need to learn the formulas off by heart. There's no formula sheets until grade 12, and by then it's too late because you've memorized everything anyway. So here we have our a is 4. We don't know the n because we're just finding the general term, and the common difference is negative 2. And here you can see why putting in the brackets to multiply really helps. Multiplying this out then, the negative 2 times n gives me a negative 2n, but negative 2 times negative 1 gives me a positive. Okay, then I'm going to rearrange it so that the number with the n goes first according to convention, and then I'm going to collect my like terms with the constants and pop those over on the right hand side. Okay, the second question is to find the 30th term that is in this sequence. And of course we're not asking you to write this up to T30 and copy and paste, we're saying use the formula. Okay, so again, I'm writing out the formula. And I need to remember that what this is asking me to do is to find the value. It is a value question and not a position question, which means I'm finding what T something is, in this case T30. I'm not finding what N is because they're telling me. They're saying the position is the 30th position, so 30 is what gets subbed in. So it's going to be negative 2 times 30 plus 6. If you're in any way uncomfortable with doing this in your head, then use the calculator. But my advice would be to do it in your head when it's for homework and the marks don't really matter. And if it's in an exam, rather use a calculator to be really sure of yourself. Okay, so negative 2 times 30, I'm going to get me negative 60, and then plus the 6 there, which gives me negative 54. Next question. Which term has a value of negative 60? So remember, they've given you the value. They're saying that the value of the term is negative 60. So what they're asking for is the other thing. They're asking for the position. So they're asking for the n. That's pretty much the only mistake you can make with these basic questions, is mixing up these two. Okay, so again, I'm going to write out the formula as is. And then remember, what I'm subbing in is the bit that's the value, so the Tn, the negative 60. So I'm going to say negative 60, and what I'm trying to find is this n. And now I'm solving the equation for the n. So taking the 6 to the other side, I'm going to end up with negative 66. That gives me negative 2n. I'm dividing both sides by negative 2 to balance the equation. And what I end up with is n equals 33. So what does that mean? That means that T33, that's the position, its value is negative 60. What can be quite intimidating about a number pattern problem that's got pictures is that you're not entirely sure what's going on. So before even reading the question, what I would advise you do is you figure out what can they possibly be counting and how many sequences could they get out of this. Now this is a classic example where there's dots and lines. Okay, so there'll be a pattern for the lines and there'll be a pattern for the dots. So what I would do is I would add to the diagram on the question paper or in the textbook how many dots I'm seeing on every single picture. So I'll just say how many dots there are. Okay, for each of them, and then I will do something different with the lines, and I will write down the number of lines for each of them, and then from that I'm going to draw a number pattern. So what you can see is that if I just focus on the actual numbers, I can then get this to look like what I'm familiar with, which is an ordinary number pattern. Then I'm just going to write that as it is. So I'm going to say that's 5, 8, 11. Okay, and I can find a Tn for that. If it's going up in a linear way, which it is, because that's going up by 3 and that's going up by 3. Okay, so we can assume the rest of it will. And then for the lines pattern, I'm going to have 5, 10, 15. That's quite simple. You can see it's basically multiples of 5, but just to be certain, I'm going to check the common difference, and it is 5. Okay, so that can also have a Tn. One of the first questions I normally ask with these is draw the next two patterns, and then of course you're just going to add on. But if you're not drawing inclined, don't worry if you can't get those, because the ones that come after that tend to be find the formula or which pattern will have 54 lines or something like that. Okay. Another helpful hint to get this into a format that is familiar to you is to say, write it down on your drawing. That is pattern 1, that is pattern 2, that is pattern 3. So this will be T1, that will be T2, T3. So you can recognize that when they say which pattern, they're also basically saying which term. So they're asking for the position. Right, subbing into my formula here, I've got my first term is 5, and then I'm putting in 3 as my common difference. So finishing that off, I've got 5 plus 3n minus 3, which is going to give me 3n plus 2. So that's my formula for the dots. My dots formula is there, so if they want dots, I'm then going to be using this formula. With my lines, I've got my first one is also 5, and my constant difference is 5. So that gives me 5 plus 5n minus 5. So that's actually just 5n. And those are okay. You can see it's just 5 times the term number. So if the term number is 3, it's going to be 5 times 3, which is 15. So these ones are nice and simple, and don't get worried by the fact that there isn't a constant as well.